So today our topic that we are having, that is chapter number 8, and this is basically the acid, base and salt. Okay, if we talk about the acid is basically having a sour taste, and if we talk about the base, that is basically bitter taste. Okay, so we are having the theories through which theories we are having three theories, and these three theories are there, three concept or theory, you can say that. So they were the three scientists who explained the base and acid. Base and acid. So today we will discuss about the base and acid. Okay. So first of all, we will discuss about we are having the three process, that is ionization, protonic concept and electronic concept. But today we will discuss about the ionization concept. Okay. Ionization concept. Okay, so if we talk about the ionization concept, so we are having a lot of, like, we are having you can say that the next two concept too, but today we will discuss about the acid base with the help of the ionization concept. So this concept was given by the Arrhenius. This is basically a scientist, Arrhenius. He defined basically the base and acid. Okay, he said that there is the chemical compound in the aqueous system, means in the water, aqueous system. Without water it cannot be ionized. So the compound should be in the aqueous system, so through which you can identify this is a base or a acid. So if we talk about the acid, he said that a compound is a acid when it is releasing the hydrogen ions in water. And if we talk about base, so he said that the compound that is releasing OH ions in water, that is called base. Let's see how. So if we talk about a compound that is basically okay, so if we talk about the acid, so acid, if we talk about, so that is, for example, we are having a HCl. You can take the example of H2SO4. Okay, you can take the example of H3PO4. Okay, so these are what? These are the acid. How? Let's see. If we are ionizing HCl in the water, okay, in water, so it is converting into the hydrogen ion plus chlorine ions in the aqueous form. Okay, so it is releasing what? Hydrogen ion. So which means that hydrochloric is basically a acid. You can take the example of H2SO4. Okay, if this is basically, if this compound is in water, so it will convert into the 2 hydrogen ion plus SO4, aqueous. So this is also releasing hydrogen ion, which means this is the acid. Okay, if we talk about a compound we are having, that is basically, we can say that H3PO4, and in water this is basically releasing the 3 hydrogen ion and PO minus 3. So this is releasing also hydrogen ion, so we can say it is an acid. So these all are the example of the acid. Okay, in the next video, not in the next video, after that we are having base, which is releasing OH ions. For example, yeah, one thing I want to tell you, that ionization basically depend on electronegativity. If we talk about the electronegativity of the HCl, that is more, and if we talk about this one, so this is less electronegativity. So they are having more electronegativity, so which means that this HCl is basically the strong acid, just because of the more electronegativity. If we talk about this one, it is having less electronegativity, which means it is weak acid. Okay, so weak acid. Okay, If we talk about base, so which means what is base? When this is hydroxide ions are releasing in the water, that is basically base. Okay, so if we talk about the example, that is sodium hydroxide, calcium hydroxide, okay, potassium hydroxide in water. So if we talk about this one, so it is releasing the sodium ions and you can say OH ions. Okay, if we talk about this one, so this is basically a, you can say that the calcium hydroxide. So this is basically wait a second. This is basically will be converted into the, you can say in the calcium ion and hydroxide ion. If we talk about this one, so this is basically the positive, negative. If we are putting potassium hydroxide into the water, so it is converting into the ions, which is basically potassium and hydroxide. So the releasing of a hydroxide ions in the water, that is called base. So these all compounds are releasing hydroxide ions, so these all are what? These all are base. But if we talk about this one, so base basically depend on the ionic character, and the acid was depending on the ionization character with just of what? Because of the RNS theory. But we are having many concepts on that. These are not based on the hydrogen and hydroxide, but according to the RNS, the acids are who that basically release the hydrogen ion, and base are what? That release the OH ions. If we talk about the base, so this one is having, this is more strong base. Why this is strong base? Because of the, as you guys all know, I told you guys the base basically depend on the ionic character. Okay, if we talk about the, let me tell you the how ionic character. So first of all, let me tell you, if we are comparing the calcium and potassium. Okay, if we talk about calcium is having 20 electronic number. Okay, if it for in first shell, this is there 2 electron, in second shell, in third shell 8 and 2. Okay, if we talk about the potassium is having 19 electron, which means this is 2, 8, 8 and 1. So this one is having more ionic character, because as compared to calcium, the nuclear effect is more. Calcium is basically having a more nuclear through the nucleus, they are having more attraction just because of the electrons. There are more electrons, so they are having more, you can say that, nuclear effect. But if you talk about the potassium, so the one electron is less in the potassium as compared to calcium, so the nuclear effect of the potassium as compared to calcium is less, and this is more. So they are having less, you can say that the nuclear effect, so it will easily lose the electron very fast, and this will not easily, it will like lose the electron but not fast. Okay, so that's why we are basically, if we are reading this here, you can see that if we talk about this one, so here you can say that the one electron is less here and here is more. So potassium is basically having the more strong base, just because it can easily lose the ions or electrons. Okay, and they are having more nuclear effect, so it will you can say that release the ions very less. Means like it will release, but after some time. Okay, so that's why we are calling that as a strong base as compared to the calcium. If you are comparing sodium, okay, so sodium is having, basically you can say that sodium is having the 11, so 2, 8 and 1. Okay, so as compared to the potassium, if we're talking about, so they are having 19. So they are having, you can say that we are having this one, but as compared to the potassium we are having 2, 8, 8 and 1. So here you can see that they are having less nuclear force. Because of this less nuclear force, because they are more, you can say that the shielding, these are more shielding, so it can, they are having less nuclear force. If we talk about this, so they are having more nuclear force, they are having more nuclear force. So it will, they are having more nuclear force, so their ionization character is less. If we talk about this one, so their ionization character is more. Okay, so that's why we're calling that as a strong base, and this is the weak base. Weak base. Okay, so it can easily lose the OH ions. If we could talk about the this one, potassium. Okay, so this was about the ionic character, and this was about the acidic character. In the next video we will talk about a Bronsted and Lowry theory on the acid and base. Today we have discussed only the one theory. The next video we will discuss about the second theory.